Welcome to Introduction to Acoustic Echo Cancellation. In this module, we will provide an overview of acoustic echo and echo cancellation. You will learn what causes acoustic echo, how to identify acoustic echo, basic functions of the acoustic echo canceller, and advantages of distributed echo cancellation. Before we discuss acoustic echo cancellation, it is important to understand what acoustic echo is and what causes it. This diagram represents two audio conference rooms connected together via a phone line or some other type of network connection. If I'm in room A talking, my microphone will pick up my audio and transmit it to the loudspeaker in room B. My audio is then heard by the people in room B, which is the desired effect. However, my audio is also picked up by the microphone in room B via direct path from the loudspeaker and indirect after multiple reflections off of the surfaces of the room. That audio, along with the local speech from room B, is sent back to room A. The result is that I hear an echo of myself whenever I speak. This is acoustic echo. Not all echo is acoustic echo, so how do you identify that the echo you are hearing is acoustic echo? Because of the path that my audio took from room A, across the network through room B, and then back across the network to room A, there will be a noticeable delay to the echo. Other equipment that processes the audio can add additional delay. This delay is a good indicator that the echo is acoustic echo. Let's have a listen.
Acoustic echo is a common problem with audio conferencing systems. It originates in the local audio loopback that occurs when your microphone picks up audio signals from your speaker and sends it back to the other participant along with your voice.
It is also important to note that acoustic echo is generated at the distant site. If I'm in room A and I hear an acoustic echo when conferenced with room B needs the acoustic echo canceller. Because of this, another indicator that echo you are hearing is acoustic echo is that it stops when the distant site mutes their microphones. As previously mentioned, to remove the echo that room A is hearing, we need an acoustic echo canceller in room B, as shown here. This diagram is a simplified representation of the acoustic echo cancellation process. The process starts with the acoustic echo canceller, or AEC, sampling the audio coming from room A before it is sent to the room B's loudspeaker. This is the AEC reference signal. The AEC reference tells the echo canceller what to cancel or remove from the transmission path. After the audio coming from room A is sampled, it continues to the speakers in room B, where it is picked up by the microphones. This audio or acoustic echo is now part of the transmission path, which is sent to the AEC along with the room B talker audio. The AEC reference signal is inverted and is also sent to the AEC. The AEC digitally subtracts these two equal but opposite signals, eliminating the acoustic echo from the transmission path. Because the talker audio in room B was not part of the AEC reference, it passes through to room A. However, in the real world, the AEC reference does not match the returned echo exactly. There are differences because the echo is altered slightly by the room as frequencies interact with the surfaces in the room and each other, resulting in residual echo. To resolve this, the AEC has an internal filter model that detects residual echo and uses it to adjust the AEC reference signal until it matches the acoustic echo coming from the room. This is an ongoing process called convergence. The last component in the acoustic echo cancellation process is the NLP, or nonlinear processor. The NLP is best described as an intelligent suppressor that recognizes and removes any remaining residual echoes that may occur after echo cancellation. Proper calibration of the audio conferencing system is critical to NLP performance and maintaining full duplex by preventing unwanted suppression of the local talker's audio. The last component of the acoustic echo cancellation process is the conference environment itself. Room acoustics, microphone and speaker placement, and microphone pickup patterns all affect the amount of audio from the loudspeaker that will get picked up by the microphone. In other words, how much echo is picked up by the microphone. ERL, or echo return loss, is a measure of the room's echo cancellation performance. ERL is the loss in level of the received audio or acoustic echo as it travels between the speaker and the microphone, including mic and loudspeaker gain, the difference between point A and B. ERL is directly proportional to the amount of acoustic treatment and mic-to-speaker distance. Directional mics will also improve ERL by limiting loudspeaker to mic coupling compared to an omni mic in the same location. Improving ERL improves the performance of the acoustic echo canceller and the NLP. The performance of the NLP is not only dependent on the performance of the echo canceller, but also proper detection of the talker audio versus acoustic echo. This involves many factors, but most importantly, the talker audio at the microphone should be higher in level than the acoustic echo picked up by the microphone. Improving ERL is a major contributor to improving talker to echo ratios at the mic, ensuring an intelligible, full duplex audio conference. ERLE, or Echo Return Loss Enhancement, is the loss in level of the acoustic echo that the echo canceller adds, the difference between point B and C. Distributed echo cancellation. Traditionally, echo cancellation was done with a single channel echo cancellers, which used one echo canceller to cancel echo picked up by all microphones in a room. CleareOne's distributed echo cancellation assigns an acoustic echo canceller to each microphone. There are many advantages to distributed echo cancellation, including faster convergence, where each echo canceller only has to deal with the dynamics of the acoustic echo at its mic and not the composite of multiple mics. Overall AEC and NLP performance is not dependent on one poor performer in the system, resulting in better overall duplex compared to a single channel echo canceller. A separate AEC reference for each microphone, which opens up multiple application possibilities such as room combine and divide applications. Another major advantage has nothing to do with the echo canceller. CleareOne's distributed echo cancellation puts the echo canceller prior to the mic mixer. A function of the mic mixer is voice activation. Because the acoustic echo has already been removed, there is little or no chance that audio from the loudspeaker, the acoustic echo, can falsely activate a mic as it can in a single channel echo canceller, where the mic mixing functions have to occur prior to the echo canceller. All CleareOne audio conferencing products use distributed echo cancellation. So how can we improve the performance of the acoustic echo canceller? Acoustic treatment improves ERL. Move microphones closer to talkers. This improves ERL and the mic and talker to noise ratio. Use directional microphones to minimize acoustic echo and noise pickup. Maximize microphone to loudspeaker distance. Proper input levels ensure a good quality audio signal at the AEC reference. Proper levels at the microphone input. Minimize noise. Excessive noise can limit AEC performance. Volume and mute changes should be done at the conference unit. For example, push-to-talk mics should control the conference unit mute and not the mute at the mic. Muting at the mic will cause echo each time the mic is muted or unmuted. This is because the AEC reference will not see the change. Muting within the conference unit will eliminate this problem. The exception is to use push-to-talk mode, available in the CleareOne Converge Pro and Interact conference systems. Do not connect back-to-back echo cancellers. This can occur when using video conferencing systems with echo cancellation. You should disable the echo canceller in the video codec. Doing the opposite effectively turns your system into a single-channel echo canceller and is not recommended. Anything you can do to improve acoustic echo canceller performance will result in improved audio quality and intelligibility. Time for a practice quiz. First question. Which of the following is a characteristic of acoustic echo? A. You hear an echo of yourself with noticeable delay. Second question. Which of the following does not improve ERL and/or AEC performance? C. Using omnidirectional microphones. Third question. What is the function of the AEC reference? Correct answer is B. The AEC reference tells the echo canceller what to cancel. Last question. Which of the following best describes the advantages of distributed echo cancellation? The correct answer is D, all of the above. This concludes Introduction to Acoustic Echo Cancellation. Thank you for your time.